Assalamualaikum everyone, my name is Aiman and in this video I'm going to talk about number types in Java object-oriented programming. As we all know, we have data types in Java, so in this video I'm going to talk about number types. So basically number types are divided into two. We have integer and we have floating point. Integer can store whole numbers either positive or negative, such as negative 456, 123, and it has no decimal places. And for floating point, it can store fractional numbers, so the numbers that have decimal places. It can be 1 decimal places or more than 1 decimal places. And you could also use floating point to store scientific numbers which use the letter E to indicate the power of 10. Now, let's look at the primitive data types for integer. We have 4 primitive data types for integer. Firstly, we have byte, which has a lower bound of negative 128 and an upper bound of 137. As you can see here, the upper bound is the positive value of the lower bound minus 1. And next we have short. You can store numbers from negative 32,768 and the upper bound of that will be the positive value of that minus 1. Next we have int. You can store numbers from negative 2,147,483,648. That is the lower bound. The upper bound of that will be the positive value of that minus 1. So as you can see here, we are getting into the billions here. To make it easy for you to get to understand how big that number is, we have 1000, and then a million, and then a billion. This is how long the number is for int. Next we have long. Long can store numbers from negative 9 quintillion, 223 quadrillion, 372 trillion, 36 billion, 854,775,808. That is the lower bound. The upper bound of that will be the positive value of that minus 1. And as you can see here, the number is very big, right? So let's get back to the billion. We have the 1000, and then we have the 1 million, and then we have the 1 billion, and we have, after that we have 1 trillion, and then 1 quadrillion, and then 1 quintillion. This is how long long can actually hold. That's why we name it long. Yeah, just that's why. And then if you were to write the value of long, you need to make sure to put an L after it. Now let's look at the primitive data type for floating point. We have 2 primitive data types for floating point, which is float and double. Float can store decimal places of up to 7 decimal places, and it can store scientific numbers from 3.8e negative 38 to 3.8e positive 38. And when you write the value for float, you need to make sure to put an F after the value. Next, we have double, which can store decimal places of up to 16 decimal places, and it can hold scientific numbers from 1.7e negative 308 to 1.7e positive 308. And when you write the value for double, you have to make sure to put the letter D after the value. Now, let's look at the non-primitive data types for integer and floating point. For integer, we have big integer, and for floating point, we have big decimal. I'm going to show you how this works by looking at this demo. Alright, now let's take a look at the demo for int, long, and big integer. So first here, this demo is going to run a factorial, which is going to be calculating factorial here. And now I'm telling the system to calculate it using the data type of int. So when you run this is the output that we get. So as you can see here, starting at 17 factorial, the number is turning to negative. When the result is turning to negative, in spite of not having any negative value, this means that the numbers is getting bigger than what the data type can actually hold. So, and eventually down here at 34 factorial, you can see that the number completely turned to zeros. Now, I'm going to show you what will happen if we run this and ask the system to actually run the number using a long data type. Now here is the result for when we use long as the data type. So as you can see here, the number is extended a lot further than before, but then as you can see, there's this negative numbers here, basically meaning that even long cannot hold the numbers that's going to be produced starting from here, like 21 factorial, and even down here at 66 factorial, the number is just 0. It's completely out of bound by long. So this is when we need to use big integer. So now I'm going to show you what will happen when we use the class big integer. So now I have told the system to use big integer, and when we run this, As you can see, there's no negative and there's no zeros. This shows that big integer can handle this very big numbers that even long and int cannot handle. So as you can see here at 99 factorial, there's actually more than 150 numbers in here, but it's not a problem for big integer to actually print out the numbers. Okay, that is the demo for integer. Now let's look at the demo for floating point. Okay, here I'm going to show you the demo for the big decimal. So here I have the big decimal up here. I've imported the big decimal class so that we can use big decimal, and then here I already assign a value to big decimal here, and then here I write the fractional value for float and double, and when it print out, it would print out the number in decimal places. It wouldn't be in fractional form, but it would be in decimal form. So when we run this, so here's the output. So this for float, I'm making it so that it print out like 7 decimal places, and this for double, I make so that it would print out until 16 decimal places, as you can see here. So and down here, this is the big decimal. As you can see, it can print out all the numbers that I put out in here. So now what will happen if I were to actually make it like out of bound for both of these, for both of the double and float. So when we run this, they would actually try to print out like exactly like 20 decimal places, but when the decimal place is out of bound, it was starting to turn into zeros, as you can see here. So as you can see, this float, this double, and this is big decimal. That's all about numbers data type in Java object-oriented programming. I hope this video will help you guys to understand number types better, and I hope to see you guys in the future. Assalamualaikum.
したかきくけこんなにもさしすせソフトクリームゴーゾロップで